First of all, check the numbers with index, and over here I have 64 and 8. So find the relationship between 64 and 8. 64 is 8 power 2, so I can write this as 8 squared power x equals to 8 power x plus 1 minus 16. Over here, I can play with the property a power mn equals to amn. So now this will give me 8 power 2x equals to 8 power x. This can be written as a power m plus n equals to a power m dot a power n. So I can write this as 8 power x multiplied with 8 power 1 minus 16. So now I will solve 8 power 2x is equals to 8 power x multiplied with 8 minus 16. Next step, I'm going to find, when all my bases are the same, I'm going to find the relationship between the index. So 2x and x, I can use the common one, that is x. Now I can write this in the form of 8 power x, everything to the power of 2 equals to 8 power x multiplied with 8 minus 16. This is now the same. So once they are the same, I can let y equals to 8 power x. So I'll get y squared equals to 8y minus 16. Over here, this is a quadratic equation, so I can get y squared minus 8y plus 16 equals to 0. Factorizing using a calculator, you get y minus 4, everything to the power of 2. This will give me y equals to 4. However, I'm not interested in y. The question wants me to find x. So I'm going to find what is x when y is equals to 4. Go back to the substitution. 8 power x is equals to 4. Okay, check the base first. Find the relationship between 8 and 4. 8 can be written as 2 power 3. X can be written as 2 power 2. So this is 2 power 3x equals to 2 power 2. Now when the bases are the same, I can make a conclusion that therefore the index are also the same. 3x is equals to 2. So x is equals to 2 over 3. For question number 2 now, we have a combination of two fractions, and for these two fractions, we have surds at the denominator. Now to get rid of the surds at the denominator, I have to rationalize. So I'll do one by one. 1 over 3 minus surd 5. To rationalize it, I will multiply with the conjugate, that is 3 plus surd 5. And then over 3 plus surd 5. Then I solve the one with minus. This is 1 over 1 plus surd 5. I multiply with 1 minus surd 5, everything over 1 minus surd 5. So now I'm going to expand, I'm going to multiply them. Numerator with numerator, denominator with denominator. This will give me 3 plus surd 5. At the denominator over here, these two are conjugates of each other, so we can use our shortcut, that is front, front, back, back. So this is 9 minus 5. Minus with 1 minus surd 5, everything over. Again, these are the conjugates of each other, so I can do front, front, back, back. So I will get 1 minus 5. Now solving it, I'll get 3 plus surd 5 over 4 minus 1 minus surd 5 over negative 4. So now I can write this as 3 plus surd 5 over 4. Okay, take a look at this. Negative, negative will produce a positive. Then I'm going to copy down 1 minus surd 5. Everything over 4. So since the denominator now are the same, since these two numbers now are the same, I can combine them into one big fraction. This is 3 plus surd 5 plus 1 minus SURD5. And notice that SURD5 minus SURD5 will cancel out. I'm left with 3 plus 1, that's 4. 4 over 4, the final answer is 1. Now for question number 3 for logarithm, first of all, check the base first. Okay, this is a very straightforward logarithmic question. We have one single log at the left-hand side and also another single log at the right-hand side. The next step we consider is our bases. Make sure they are the same. 9 and 3, we find the easier one, which is 3. So at the left-hand side, I'll change the base. I will use base 3. So log base 3, over here, we go backwards. Okay, when we change base, we go backwards. So here I have log base 3 x minus 2 over log base 3 of 9. At the right hand side, I have log base 3 of 4. So now log base 3 of x minus 2 over 9 and 3. We find a relationship between 9 and 3. We know that 9 is 3 power 2. So this is log 3, 3 power 2. I can use the property log a power b to be equals to b log a. So I'll bring the power down to the front. Now I have log base 3 x minus 2, everything over 2 log base 3 of 3. Log base 3 of 3, I can cancel it out as it will produce 1. So I'm settled there. I have equals to log base 3 to the power 4. Over here, I have 2. I can bring it to the right-hand side. When I bring it to the right-hand side, I will multiply. So now I have log base 3 of x minus 2 equals to 2 log base 3 of 4. I want single logarithm, so I don't want any numbers in front. I'll raise it up to make it a power. Still using the same properties from just now, the one with powers. So now I can do log base 3 of x minus 2 is equals to log base 3 of 4 squared. So log base 3 of 16. Here is log base 3 of x minus 2. Take a look at both the left-hand side and the right-hand side. Both have only single logarithm. The bases are the same. So I can say that the numbers that are being logged are also the same. So the conclusion that I'm going to write is x minus 2 is equals to 16, so x is equals to 18. Now for question number 4, we have 3 linear variables. And to find the variables x, y, and z, I have to do simultaneous equation. So first of all, what I'm going to do is I'm going to name them. This is equation 1, equation 2, and equation 3. And then I determine which one I want to eliminate. So over here, I've decided to eliminate my x. So my objective is eliminate x. So in order to eliminate x, I will do equation 3 minus equation 1. Now I will get z equals to negative 1. Once I get z equals to negative 1, I'll check into any of the previous equations. So I just need to find one equation where I have z and I can find the other variable. So over here from equation 1, 2, and 3, I found that equation 2 is the most useful. So I'll substitute z into equation 2. So now I have y plus 2 multiplied with negative 1 equals to 3. This is y minus 2 equals to 3, so y equals to 5. I have z and y, so now I'm left with x. So looking at my 3 equations, I found my equation 1 to be most helpful to me. I can find my x, and then plus 2, my y is 5. So solving it, I have x to be equals to 2 minus 10, which is negative 8. Now I can make a conclusion. Therefore, x equals to negative 8, y equals to 5, z equals to negative 1.